Okay, we're live on YouTube now.
Okay.
I'll get to see it now.
There's certain, you're going to show things you can't have a background on. I'm going to shut this off for now.
It looks like the video is running about 14 seconds behind.
And when you're ready.
Hey, Bob, I got some artifacts.
Yeah, you know who took this picture? It was Dan.
Oh, yeah.
Actually, if you step back enough, you can maybe read this.
You might be able to see the barrel. It's got a little bit of barrel from the lens. I mean, I used a long lens to do it, but it was a 135.
Mm-hmm. I mean, those days getting screenshots. It doesn't even look like a screenshot.
They were literally. But Bob, I got one of these.
Oh yeah, I could. Yeah, I should have gotten. Okay, good thing you have it.
Yeah, this is one. This is from November '79. It says on the disc.
Yeah.
Now I have the left-right issue.
Yeah, I mean, you see how hard it is to show
Yeah,
things. Oh, actually, this is a good one.
Oh. Oh, look what I got.
Oh.
Does this still work after all these years?
I haven't tried it recently.
Well,
I have to get my PC out. I mean, my Mac, my Apple II.
We can go out to the bike shop.
No, well,
I'm sure they would like to make a copy.
yeah. So this is the one. This is the one we ship with because it's the 135 version.
Yeah, this one says doesn't have a number on it. This is 979. 135. This is 135.
Yeah, 135. That's the one.
Right. Yeah, I've got the artifacts, but I was going to talk more about the technical stuff, so I didn't think it was getting.
Right, I know, but I have that in case you
want.
Oh,
it's good. I mean, yes.
To spice it up a bit, if you want, but you're going to talk about the detail about developing it, not me.
Yeah. Well, you did. I mean, one of the points I'm going to remind people is that the only reason I wrote it is you were too busy at school.
Well, you also knew how to use the tools.
Yeah, but you're not exactly new at programming.
No. I designed some of the memory layout. And the memory allocation and why we use that memory allocation mechanism.
Yeah, I remember Bill Gates asking about it. For some reason, he disassembled it.
And 123 used how to use a similar one, I think.
No, the thing is, I used a heap, and since then I was thinking maybe there were other approaches. Oh no, actually,
no, but
you had a combination of
it's of equal of the size of every memory unit was the same.
Right. No, we had that's part, but there was another part that was the row table thing that was actually variable and changed because.
Yes. Right. That
yes.
layout. The thing is, one of the important things. Well, I don't know. Have we started yet? No, it's not 7:00 yet.
Oh.
There were some design decisions that we made that we should talk about.
What did I do? I hit something.
You sure did. You became BF.
Am I coming back now?
Yes. Yeah. Now you're back.
These keyboards are dangerous.
Yes, but guess what?
What?
We see your room.
Oh yeah, no, I turned up the background so I can do this stuff.
Oh, okay.
Turns out if you can't do it if you have the background on.
Yeah. And I think I might have one of the first ones, which is what we used when it was announced. Mm-hmm. That was the marketing material consisted of that reference card.
Yes. Well, that's the story. I mean, we could start now, and
It is now, yeah, it's 7 o'clock.
I mean,
You want to make sure that people come on.
well,
So do we have any idea how many people are watching on stream?
or just
Not on the stream on YouTube? No idea.
Okay.
yeah. I think again, I'd expect people to just click on this and participate. Well, maybe they're too shy.
There's one in particular that is.
You're not going to mention the name?
No.
So what I'll do is I'll take a look at it on another machine.
There are 4 watching on the live stream.
Okay.
Is one the one I think it is?
Let's see.
Didn't Apple eventually come up with their own spreadsheet? It was like AppleWorks or something.
Later, yeah, but there was
much later.
they
Works.
were going to come
Like
up with one
Works.
sooner, but they were there was some intercompany discussions that were made. We weren't involved in that.
Yes. No, you remind me of AppleWorks. It didn't really go anywhere as far as I could tell.
Yeah.
But we could discuss that, and
Okay, so right now there are 3 people watching the stream, and I'm one of them.
okay, so you're doing both. Okay.
I'm also one of them because I need to monitor it to make sure that I detected it with the video.
Okay. Oh, we have the monitors now.
So
Monitoring each other.
there are now 4 people.
Okay.
So give people a little bit of time to show up, a few minutes.
Well, I remember this is being recorded, so there's no real need if you can follow the live stream on YouTube.
Oh, yeah.
I actually like to have Jerry do an introduction before the presentation officially starts.
Okay, that's fine.
Because afterwards I go into edit, I need to be able to find a clear cut point to delete everything before the presentation.
Okay, are we ready for the intro? We're gonna give.
I think we normally wait until 7:15 to actually start the presentation.
Yeah, we can wait a little bit. Let me see who's around. A
good.
couple of our regulars aren't here yet.
Do the people that are on want to introduce themselves? Because I don't know, I'm not good remembering people, and I probably haven't met some of you.
Yeah.
Well, I'm John Abreu. I'm the founder and executive director of Boston Linux Unix. We originally founded as a subgroup of the Boston Computer Society. But then when they went bankrupt, we decided to continue on as an independent group.
I'm Paul Jameson. I'm observing this. I'm not much of a computer. I like using Linux, but I'm no expert in programming and things like that. I'm more of a physicist, mathematician.
Oh, so what are you interested about? What do you expect Bob to talk about?
Well, I'm interested in the beginnings of calculations, and I know I used to work at BBN, and I know there was a lot of talk about the beginning of the internet. But
Well, that's a whole other discussion.
yeah, true.
Well, after
I'm a curious person, so that's why I'm here.
oh, that's fine.
Okay. Hey, Paul.
And I'm Jerry Feldman. I've been with Boston Linux and Unix since John founded it. And I was on the board of directors of the Boston Computer Society when we decided to vote it closed. So that was it. And as you know from our previous discussion, I was at Dan's presentation of the New England apple tree shortly after I moved from San Antonio up to Boston.
Yeah, I remember finding out about that a little early. I was telling it in to the BCS mail server doing some administrative work, and I needed someone in the office to reboot it. So I called the office, asked that, and they told me everything's down, the power's out, nothing's working. And the thing was obviously live when I saw it, so I knew something was fishy going on. Then I called Jerry, and he let me know what was going on.
And there's a cat watching.
I'm sorry.
Anybody else?
Which mountain is in the background? Oh, that's the stock mountain thing.
Yeah, I have no idea what that is. It was the one that didn't look like an empty office, so I took it.
Okay.
So no idea whether it's a real mountain or just some CGI thing.
This is just what came with Jitsi.
Yeah, it's a built-in. I recognized it.
My wife watches all mountain climbing videos. I could ask her, and she'd probably be able to identify it immediately.
Yeah, there are like thousands of, maybe hundreds of thousands of mountains around the world, and I think there's maybe 5 or 6 that I actually recognize on site.
Oh,
And I've only climbed about 2 or 3.
And I've climbed 0. Walked up some hike things, but no climbing as such.
like Monadnock or something like that.
Well, yeah. No, I do remember looking for trilobites and sliding down a few hundred feet.
I've landed a helicopter on top of a couple.
You win.
And then running after the helicopter that slid down.
I actually crashed one on top of a mountain.
How'd you get down?
How much do people want to hear about the internal bits and bytes and stuff like that?
Yeah,
There's
sure, that'd be-
one, there's 2, there's 3,
Yeah. I'm
4.
definitely curious about the data structure.
Yeah, okay.
Yeah.
So
Like, was the cell, like, was the spreadsheet like a 2-dimensional array?
not really, because that would have taken up too much.
But you'll go into in great detail
Yes,
in 5 minutes or so.
yes.
And we
Remember, 32K, 16K was it was designed.
right.
We failed.
Well, that was the cassette version.
No, it was the only version. The disc stuff, even without the disc stuff, it was still failed.
Yeah, officially it ran on 32K.
Yes. This is one of the things is we think we're very careful. Remember, it turns out there was no. More and more, we learned later there was no price problem. People would have paid anything.
Well, because it was thousands of dollars anyway, because you had to buy an Apple II
Yes.
and a printer and a Sony TV
Oh,
and the disk drives.
Then there was the story of software. The people bought USD Pascal. Okay.
Oh, yes.
I remember.
Yes.
So basically, UCSD Pascal was selling very well. They didn't realize that the deals were all taking the board out of the box, throwing away the Pascal stuff, not to confuse people.
So the UCSD Pascal, which was an interpreted system, required more memory than a normal Apple II. Apple II could only go up to 48. So there was this board, as Bob's talking about, that had 16K more memory that you could plug in so that you could run UCSD Pascal. And they sold the whole thing for what, $495 or something?
Well, yeah, I don't remember.
$495 or something. So as you're saying, what happens is they were selling lots of UCSD Pascal. People didn't realize why. Somebody bought the company, not knowing that the reason everybody was buying UCSD Pascal was to throw away UCSD Pascal.
Why am I having trouble remembering the name of the company? Because I knew the people in the building.
Yeah, but you supported it, Bob, because you put support in VisiCalc for that.
Yes.
Except for the last how many bytes?
Is on.
I had something. No, I mean, it pretty much used all of it.
No, but there was like a handful of bytes you couldn't use or something. The last, I don't know, if it was like 4 bytes or something.
Yeah.
I don't know. There was something.
No, there are all these little kludges. The amazing part were the people who patched it for additional memory and other features before we did. The whole disassemble and do it, patch it world.
Right. I remember Gates telling you and me, I guess, about, well, you did it this in such a way. And we said, no, we didn't. He said, no, we disassembled it. And that's what it says. And I said, no, it's not that way.
Well, actually, I'm going to get into why the people who disassembled were at a severe disadvantage, and I was amazed they figured it out at all. Because, well, I'll start. I could get into. We can start
Should
now.
we start, or are we going to wait till a quarter after?
No, we might as well start. There's nothing religious.
Okay, we can go ahead and start now.
Okay.
Yeah, there's 6 people, and the other new people aren't coming in here. So
Okay, let me start out. I mean, there are various origins. Like when Dan and I met in 1970, decided one day we're going to do business. But my particular sort of path to be able to program, as Dan said, the Apple II, there was a company called ECD, which made capacitors for me to decide they were going to make a PC, which is a whole story in itself. I mean, it's a 16 megabyte multiprocessor, everything PC, with one mistake, design error. They didn't realize you have to make it for less than you sell it for.
how much did they sell it for?
A few thousand.
No. Wasn't it like 9876?
Oh yeah, yes, yes. You're right. An arbitrary number. It was a very sophisticated machine, over designed by an order of magnitude, but it gave me a lot of practice for writing 6502 code, which was just, again, fortunate. And you should look at the whole 6502 history. But one of the things there, again, this is going to be out of order, but I'm going to try to keep it sort of chronological, was a macro package, so that, which I then refined in order to write.
This is the assembler, that ran on.
Well, first it ran on there's one that ran on Multics.
Okay. That's what you originally wrote it on, was on Multics, which is the MIT time sharing system that we both worked for.
Yes. At midnight, basically third shift time was cheap. Only cost $1 an hour.
And ECD had a
ECD had tools on Multics, which was convenient. And we were competing with the Ada development team, which was dialed in from France in the middle of the night, in the middle of our night. It was their day. But the main point is the Apple II, we need to program an assembler in order to fit. And even though I didn't like the idea of assembler, it was the appropriate thing to do. With the macro package, it was actually quite doable. So because I first saw the Apple II as a toy computer, but by 78, and we can go into why I chose the Apple II. I first did a project with personal software for practice, just for the heck of it, porting a bridge from the TRS-80 to the Apple II. So I was using the Apple II. Again, each of these is stories own right, but when Dan had the idea, was busy, I had these skills. We figured it had to be an assembler because there was no room. I mean, remember, we're going for 16K. Now, most people on the call can conceptualize that. So I'm curious if Ben looks like, did you ever use a 16K machine?
No, I did not.
Okay. That's only 1 millionth what we have now. My desktop is 4 million times that. But
back my freshman year in college, we had a 16K PDP 1134A.
Yeah,
actually 2 of them. One was time share and one running single user mode for the graduate level classes.
Time sharing 16K might have been a little low for time sharing, but there was a Unix that was stripped out for even smaller machine on the 1105. But
which I had programmed for before. 1105, not
1105. Yeah, and it was. I mean, we knew how to make things small in those days.
PDP-8s.
Yeah, I mean,
I programmed for a 512 byte machine.
Oh yeah, no, we could. Yes, in any case. So the key thing was all these techniques I used to save memory. For example, loops would go down rather than up because we could save 1 byte for the testing for the end case. Now, the way to go to this programming, because I mentioned the disassemblies, it wouldn't be obvious. There was no.
That was hot in those days. Go-to list programming was a hot topic.
it was a hot topic. But the reason I did it, a little aside, is I disagreed with Dijkstra on why. Because Dijkstra came at it from math. And I realized he missed the point. The point about go-to-list programming was that the static state and the dynamic state were in alignment. So you can figure out what was happening. The problem is Wirth got it wrong. And he glommed onto the single exit thing in Pascal, which meant you had all these complex switches. But in any case, getting on, so the tools allowed me to do maintainable code. But the main thing was I figured we should start with the prototype. So I remember, and I was still at Interactive Data, sitting back in a class they were giving us on something, designing the data structures. And we started prototyping it. I called the module SS init for spreadsheet init. Little did I know that's what would ship.
So people wonder, did we know the word spreadsheet? Well, the name of the code was SS init.
Yes. But the thing is, we saw spreadsheets.
Is on.
What? Did something just say something? Let me put up the chat so I can see if people are making side remarks. Oh, there's side remarks. Okay. So this is before I came up with the name VisiCalc. We'll get to that story and the arguments over that. So Dan first did a prototype in BASIC. Now, Dan, do you have the URL for your talk on this?
That part, there are a lot somewhere. I don't know where. I mean,
there's a TEDx talk.
There's a TEDx talk. It's on TED.com. If you search Dan Bricklin, TED.com, you'll find it. But it doesn't get into, it gets into some, but not all of the story of the first prototype.
Yeah. The key point is that we had to junk a lot of our programming experience. To first name variables that was obvious you need to point rather than name things. And in fact, you notice that a lot of work went in deciding this and implementing, calling it A1, and with the letters going across, numbers down, because you had to do 52 weeks, plus a spreadsheet, as Dan would point out, for production planning, not just for finance. And then so you can have, the numbers would go down, but you can have more rows.
So they could be narrower. If we did the letters at the top, then when you hit 100, you still were at only two characters wide.
Yes, but the main thing was to get 52 across. Yes, but one as an aside, in the first prototype, I gave you the ability to relabel things, so you didn't have to use the letters. And then we decided that there were too many problems in terms of the user experience by giving that much freedom. So, but I did remove the code. All I did was prevent you from going into those columns. Because again, it was the goal was, my design approach is to do scaffolding. You try to have working code all the time, because for two reasons. Number one, it's no fun if it doesn't work, to be honest. But it also keeps you honest and making it work. And because of that, Dan was able to play with it and work on the user experience while I was doing the coding. And that worked well because he was busy in school, couldn't do the coding. But because he understood the code and I understood the business goals, we were able to negotiate. So we'd want a feature, and then we could work out the budget. Is this worth putting in? Is there a way to do it? And we continue. For example, one of the features we left out was the help system.
Yep.
It was 2K.
The most minimal help system, which you ended up double using for something else.
Well, we didn't really put the help. What we did instead of the help system,
it was supposed to have help. I mean, if I look at my original, write up of the spec of stuff on it, it says here, in here was there was a help.
Yeah. Well, so
H was supposed to get you help.
And again, we compromised. So there are two things we did. Number one, the rule was if you couldn't explain it on the reference card, change the program. Now it turns out replicate was still more expensive, complicated than it should have been, because I think what we didn't do was the idea that went into Excel was the dollar sign, or the
Oh, there's Mitch came up with that.
Mitch came up with that.
Well, I don't know if it's Mitch or it's John.
Yeah,
but Mitch came up with the dollar.
So, but for the most part, we want to be. I won't get totally intuitive, but it should be possible to figure it all out.
Oh, sorry, not Mitch. Mitch Kapoor.
Mitch Kapoor, yes.
Just so you should know, for those that don't, the guy who did 1, 2, 3.
Yeah, who happened to be come to us after we showed it to him. He was looking for a job, so we recommended to be product manager at Personal Software, and later it became VisiCalc. So, he was very familiar with, the spreadsheet, and he had his own products, which we meshed with. We can get to that.
I have one up there.
So, so Dan had the prototype, and I started working from that, not implementing the spirit of it. And like remove where the entry areas and things like that. There are a lot of features we left out. For example, we thought about putting moving graphics at the bottom because the Apple II had a feature where you could mix a text screen and a graphic screen. Do you remember that?
At the same time, you could only go back.
No, there was a split screen mode.
Oh, yeah. No.
We could put bitmap at the bottom. Nobody, I think, used it for the obvious reason.
But the thing you did put in is you put in multiple. You could have 2 windows split horizontally or vertical, and both of those windows had what you might call locked panes. They call them now, and they could do synchronized scrolling. That when you scrolled one window, the other window in the same direction would scroll, but the locked panes would fit. So you basically could have 2 portals with the titles staying correctly in your 32K version of the.
And you can also do primitive graphing using asterisk by putting an asterisk mode in.
Yeah.
So there, again, all these things. Remember, in the day, even asterisk graph was a major improvement. But I'm getting a little ahead of myself because we want the guts of the implementation. So, one of the early decide was the layout. So we worked out, came up with the cellular structure, which meant, the representation, you had to look at the bytes. Where's the end of the byte? How does it continue to the next cell? But to answer the question is, we needed vectors for the spreadsheet itself because you didn't want to have the memory lay it all out. So
we didn't know if it would be hard, if you'd be a mainly horizontal spreadsheet or a mainly vertical spreadsheet.
Or a mixture.
Or a mixture.
So that's where we need to do dynamic and allocation and compaction. And part of the goal was to make sure that it was deterministic, that you wouldn't sometimes run out of memory sometimes.
In other words, if you reloaded something that used up every single byte, if you were right to the edge of every single byte, if you wrote that out and then read it back in, it would still fit.
But not only that,
again,
we're getting ahead because of the allocation. If we wrote it out A1 going down, it would have taken forever, which would be continually reallocating. So the save format went from the lower right first. And the save format was the same keystrokes you would type in. So and by the way, a lot of this still works in Excel to this day. I suspect you can load a VisiCalc spreadsheet into Excel and it'll still work.
More or less. So Bob, if I remember right, the layout was that there was an array of rows.
Yes, I think it was row first and column. Yeah.
Okay, and then each of those could go out any number.
Yes,
and that was an array sidewards.
Yes, but those are contiguous, which is why we needed the memory allocation.
So you could actually put something in the bottom rightmost corner as long as you didn't fill in a lot of other.
Yes, I'm not sure they had partial arrays, but yes, you could overflow it by, doing a lot of empty rows, but few people did that. The other thing, and I was saying, got rid of a lot of experience. We knew about Maxima and what people are so proud of. They've had a natural order of recalc. Well, the original one, the goal was to calculate to have a dependency graph, so that whenever it didn't matter which order you did it in. And one thing I realized is, we don't need to do that. Most spreadsheets go, basically people put it in order. And we did give you the ability to row first or column first. And if you did have a circular dependency, you just recalculate twice.
Right. So in other words, you could recalculate, this one, across and then across and then across and across, or down, 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 down. You got to decide that in terms of the order of recal. And it's saved, but the thing is that if we had natural order, the feeling was it would have taken up a little bit of space to keep track of that. Let's say you used the linked list.
It would have been
That would have gotten rid of maybe one third of your memory or more would go away, and people wanted every byte to be able to do very large spreadsheets.
What was amazing is how little pushback we got on that.
Yes.
Where one of the mistakes I made was, though, we could have done variable column widths, but that would have required an indirect table. I mean, one of the things I learned about programming is once you realize something, it becomes obvious. But going in, remember, performance was a real consideration, and we come from the good old days when 1 million instructions per second was a fast machine, and these were byte instructions. So
one of the things you were doing is we wanted to go as fast as the repeat key, that it could display the screen. It was redisplaying the screen as fast as the repeat key.
Actually, didn't.
What? Well, we didn't realize that each Apple II was a little different. It was an RC circuit. It wasn't a timer.
Yeah, but that's not the way I implemented it.
No,
the way I implemented it was but you bring up a good point. There was no clock. I couldn't get interrupts from the keyboard, and they could be coming in the stream. So I didn't want to lose keystrokes, because if the program was calculating, you'd lose keystrokes.
Right, and electric pencil was losing keystroke. The word processor was losing keystrokes, and that's no good.
Yeah, so
carriage return, you had to wait.
So throughout the program, it would pull the keyboard and cue up the keystrokes. But for repeated keys, it would throw away keys past what you were doing. So no matter how much you held the keyboard down, it would not scoot over. You lift the keys, it stopped.
It didn't buffer those up if it's the same key over and over again.
So, I forget the details, but basically, yeah, there might have been. I'm not sure the real repeated key, because we had to. If you type AAA, it had to work. So I think it might have been just for the scrolling. But it would be interesting to look at the code and try to remember.
So, if I remember right, so memory was broken up into chunks that were all the same size, which
not for the spreadsheet index table, but for the data. Yes,
for the data. And so therefore, I was concerned about speed of display, and I wanted the numbers to work the same way as your calculator. So therefore, not instead of using binary arithmetic, to use decimal arithmetic. I remember right, you found decimal arithmetic code in Dr. Dobbs or something.
No, what happened? The decimal arithmetic I figured out myself. What we did, I don't think it went to Dr. Dobbs for that.
No, it's the display. Sorry, the converting. The thing about decimal numbers is, first of all, decimal numbers, because I wanted it to be the same as your calculator. This was my calculator, and the other was that conversion from internal to display could be really fast.
It's theory. It turns out I screwed that up, but we'll get to that later. But the decimal thing had 12 digits, which turns out to be very useful, because somebody at Livermore had his Apple III requisition to send to Washington because they had to calculate this budget.
Well, we actually decided that.
Yes.
We decided how many digits. We basically said, what's the largest thing we would want people to be able to calculate? And it was the budget of the U.S. in dollars.
So that's why it was 12.
That's how we figured out how many significant figures to have.
Now, getting ahead of our story, one problem we ran into was Carl Helmers, who some of you might remember, wrote an article praising VisiCalc.
He was the editor of Byte magazine.
Yeah, the transcendental functions.
Which
the problem was we decided transcendental functions were too much of a pain and we were going to defer them. After he extolled them, we had to sit down, and I think Dan did a lot of work, figure out how do you compute, transcendental functions with 12-digit accuracy numbers. in decimal, but all this stuff was mostly binary. So we had to figure that out. Turns out
Well,
they're very slow, but they
You know
work.
how we did it? You know how we figured it out?
Well, you got a book you found.
Because I wrote it. It was a
Yes.
book. And who told me about the book?
Who? Carl?
Monty Davidoff.
Oh, Monty Davidoff. Oh,
What did he write as a summer student?
which? Oh,
The
which was,
Transcendentals for Microsoft Basic.
yes.
And he had done that before, I think. He told me about the book. I don't know if I still have it up there somewhere. And the book basically told you how to do, the algorithms for doing transcendentals.
So we
And-
did. It was a pain, but we did it.
Yeah,
And the trick was to do it in small space.
my only code that I got in the product was
Yes, but we had to make it fit in the small
1K.
space. Yes.
wasted a whole K.
Yeah. But getting back to the main implementation, so something, as I said, fixed column width and stuff, it was simple because we wrote directly to the screen. Now, looking back, one of the reasons it didn't move variable column and stuff, another level of indirection. Turns out that maybe for me, we realized we were actually far beyond the performance goal in some areas. Other areas are slow because we're doing this slow arithmetic. Like if you use transcendental functions, you'd notice the speed. But for the most part, it was basically an 8-bit, 1 megabit machine that was highly interactive, and that was the key.
Right. Now you could turn off recalculation if it was too slow.
Mm-hmm.
When I did my my prototype, I made it make a sound every time it recalculated a cell. So you hear tick, 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 tick. It turned out making the sound on the Apple II, which is done by timing loops, took up almost all the time. So I got rid of it, and then it went much faster.
Yes.
But, so we didn't do that. In fact, the original software that we had, if you did certain things, it would make a beep, or if you hit the edge, you try to move the cursor, past the edge, it would go bick, 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 bick. If you run the simulators in JavaScript that we have today, that run the IBM version of it, you'll hear tick, tick. You hear the stuff that's too fast frequency because it's so much faster than the old one was, than the original was. We had tuned it to the speed of the CPU.
So one of the other things we did, we did have a help system. Actually, even before that, the goal was to make it very interactive. And one of the things you learn about user interface is people think they have infinite freedom when they have very few choices, but the choices are obvious. So one of the things, when you hit an arrow key, people didn't realize sometimes it would move it across the expression, sometimes it would move it to another cell. So the algorithm was figuring out, okay, you're in a certain part of the equation, and obviously you want to move it in there. You're another thing, and obviously you want to move it to another cell.
John Reese came up with that idea.
That was John Reese?
That was John Reese who came up with the idea, because originally I had said that if you were going to say 1 plus, and then you wanted to point something, you'd push the U button, meaning I want to use that value and then point to it. And then John said, look, if you have a calculation, if you have an expression that ends with a binary operator, then pointing to something is clearly the only legal thing to do would be to be adding a cell reference to the equation. But if you put in 2 plus 2 and then pushed an arrow key, clearly you wanted to go to the next cell. You wanted to save it and go to the next cell. So you don't have to hit carriage return. My background was from computerized typesetting and word processing, where people were paid by the keystroke. And I was trying to minimize. This had to be really fast, so I want to minimize the number of keystrokes for everything that you're doing. And that minimized keystrokes, you could say 25, arrow, 33 down arrow, something, and just put numbers in the same way you would on a calculator, where you do,
One of the interesting things is Dan found the paddles were too bad to use for entering, but that was actually fortunate, because with a spreadsheet, if you have to go to the mouse, you lose. It's much faster if you can keep your fingers on the home keys. Now, one of the things byproduct of not having a help system was that we had to basically couldn't get, we all, oh, the other thing we didn't want were error messages. Error messages take a lot of space. So rather than giving you error messages, we would just show you what we thought you wanted. And you can, so if you typed add S, it would complete with sign. And if you typed add SI, we still completed the sign. We just ignored the extra characters that match our expectations. And if you didn't want sign, well, nothing happened because you didn't have any other option. So we didn't need a help system. In other words, you could not enter anything illegal.
And right. And if you can see, and no, it's not on the thing behind you. If you hit the slash key, we have slashes because I didn't like using control because it was harder for me to do that because I was born with two bent little fingers and it made it harder to push down and stuff like that. So I went with slash, just like in the old IBM systems where slash was the beginning of a command on the card systems, slash DD star, stuff like that.
Yeah. By the way,
but if you press slash, it would show you the letters that were acceptable. It said, so you would type slash and it would show you the, and what did you do? And what was that, Bob? What was that list of letters? I remember you told me it was the lookup table itself that you used to look up.
Oh yeah, no, everything was but yeah, because you didn't want
to save bytes. The prompt was actually used as the lookup table.
Yes, there was a lot of fully, but by the way, slash still works in Excel and with the VisiCalc commands.
Slash is treated the same as the Alt key in Excel.
No, actually, no. It brings up VisiCalc commands, not Excel commands.
No. Thought it brings up. No, it's the same. You can. So, like, if you type slash IR, it'll insert a row.
Okay, I might have been wrong.
Slash. You try. You use slash, and suddenly it's the same as if you push. Yeah, good. Thanks for you'll go check on Excel. I checked this sometime in the last couple months.
So if I type slash F. You're right. It doesn't do formatting.
What does slash do?
Slash does, it acts like alt. Exactly.
It's not just like alt. It turns out, so I was able to cheat and say that if you do slash IR, it inserts a row. Mm-hmm. And that's the same keystrokes that worked on VisiCalc. But a whole lot of other ones don't work.
Yeah. So you're right. But it can. But
at least some of the keystrokes are the same.
I think they can read VisiCalc, save VisiCalc spreadsheets.
They could read 1, 2, 3 spreadsheets, which could read VisiCalc spreadsheets.
Okay, yeah. I doubt whether many people use that feature. By the way, the other implementation thing.
A lot of people used it back then.
Oh yeah,
and that was in the lawsuit that Lotus went against others. They said, well, we're the way that Excel does things by reading our files directly. That's the way you should do it. So,
but one reason, a strong reason, we had to reload from the bottom right is for cassette support. The problem with cassettes is they ran at a constant speed.
You can't stop.
We had to processing fast enough to read the sheet off a cassette, and we shipped with cassette support. We just didn't tell anybody.
So this thing that you're saying that what basically the keystrokes that that basically we put in the thing that greater than was the same as moving to a place. So if we had greater than A1 colon, which was the same as a carriage return, treated as a carriage return, you could, and then you could put in what would be there. Basically, the what you could type was the same as what was saved. It was what was saved is exactly the keystrokes that were necessary for that. Really easy for other programs. Other programs could write those files, and there are companies that formed, some of which are still around, I believe, that wrote that format so that people could read data into VisiCalc. I think OutlookSoft. Outlook? No, what's it called? Not Outlook. What's the company? It's down in Norwalk, Connecticut. They're all sorts of. That's what they started with, and so companies actually had add-ins for VisiCalc, programs that would write files.
Even though it was not supposed to work, they reverse solved it. There are all sorts of hacks. like sideways, Paul Funk's company, to print
Yeah.
long spreadsheets by printing them sideways. But back to the Apple II programming. You remind me of another thing we did on the Apple II,
Yeah.
which was automatically detect what kind of cards you had in. So if you basically accessed a serial port, or what we figured out was a printer, we would print. And we'd see, and we'd have to figure out, you have a disk drive. None of this was standard. We basically figured out signature bytes by looking each card and saying, okay, how do we figure out which card you've got in there? And remember, again, we had no clock, so we had to figure out how to do all of this, dynamically. The disk stuff, we didn't want to sign Apple's agreement, because it said they could basically revoke it at 30 days notice. So I had to reverse engineer.
To put the DOS on our disks or anything like that.
Yes.
Right.
Well, we didn't need DOS. I reverse engineered Wozniak's disk format, and it was clever. I mean, Woz had some nice, clever code there. And as a matter of fact, the first file system we shipped, because I had a bug in the file system, it would overwrite the bitmap. And for the people who were careful and made 2 copies, it overwrote both copies.
Well, this was the thing we did with copy protection.
Oh, well, there's not. Yeah, that was because, well, no.
This was an initial thing. One thing was, figuring that people would copy the disk. What we did is you would write onto the disk, because Apple IIs had a write protect switch, and the disks we would ship with would have the write protect tab there, right? So that if you wrote on yourself, not a problem. Turned out Apple didn't QA those very well.
Yes.
There were a lot of disks that disk drives that the write protect switch didn't work. And one of the testers we had here was such a person, and that's how we found out about it. Yeah. Unfortunately, one of the other people was Steve Jobs.
But I should distinguish between the two things. The overriding was one bug, but I read the file system managed bitmap to show you what sectors are allocated. So that one I overwrote, but I forgot to put the bitmap of the bitmap table into itself. So that was a bug. By the way, they shipped with 13 sector disks. Then they came out with 16 sector disks. So I wrote the program so when you boot it would figure out which you had and automatically adapt to it, which very few programs did in those days.
So, Bob, what that reminds us is that here you ran in 32K bytes.
Yes.
Okay. Now that included the operating system.
That was mostly wrong, but there was a little.
The operating system that you wrote, the disk stuff that you wrote.
Include all the disk stuff. We had to write our own operating system.
Yeah, you wrote your own operating system. So included the operating system had to fit in the 32K. All of the code for VisiCalc had to fit there, and your what's it called? All of your data had to fit there, and the screen buffer all had to fit in the same 32K. It was tight.
So a 16K machine was really like a 10K machine.
So the job that you had to make this all work with multiple scrolling windows that would split with synchronized scrolling and calculation and transcendental, that was no mean feat.
It's interesting. People talk about writing small Windows programs and things. And our definition of small has changed over the years.
VisiCalc is smaller than the GIF to be able to show a screenshot.
Yes.
Of it running.
More fave icon. Yes. But again, let's see. There are all sorts of different directions I can take this in. I'm also interested in if there are any questions while we're doing this. The original code itself. Unfortunately, the original listings of the code itself are on a tape somewhere deep in the bowels of IBM because Lotus lawyers wanted to keep it around. We were stupid in that. Again, these are hindsight things. We should have made a copy of the tape. Right. It wouldn't have been that hard, but we just didn't think of it. And that.
Well, it was not cheap in those days to do such things.
Yeah, but it would have been. Again, you look back.
Right.
We should have done it, but who thinks of those things?
Yeah.
So we had the tools on Multics, but as soon as we got our own computer, the Prime, we need to port the tools. So I also had to write our own tools. So one of the tools I did was an assembler, which had all these macros, a little better than one on Multics. We need an editor. And I was playing with writing a QED-like editor. So for those who don't know, QED is the ancestor of ED on Linux. And the reason I can use ED, if you press colon, the commands or actually I don't even call it ED, but for them you do. I learned back in 1966 still work. But by that time I wanted an Emacs. So I turned the QED code within PL1 into an Emacs code.
Eventually. Initially, I wrote the first editor for you.
A simple, yeah.
I wrote a simple editor, and I wrote a bookkeeping system that we used to keep bookkeeping for our company at the beginning. And you wrote the assembler linker.
Yeah. Whatever it did to pull, the stuff to get it downloaded to paper tape, so I can put it on the Apple II.
Paper tape? No.
No, we skipped the paper tape. It went directly.
No, it was you did it through serial
file. Yeah,
serial port.
Serial port, and later we went directly with the serial port. But it was always a pain. We had to do this.
We didn't have a simulator.
Well, later, by the way, we got in-circuit emulators and things. And the interesting thing there was, I remember I was debugging a strange bug. Couldn't figure out what was happening until I noticed the bit in the Apple II. The byte changed spontaneously. We had bad memory. The advantage of in-circuit emulator. But there were, working through the night, there were sometimes we had these edge bugs, which took forever to find.
That was a hardware device that you could plug into over the chip or instead of the chip.
Replace the CPU and you could emulate it. But that was later when we were rich, sort of, and could afford.
You could afford such things. They were $1,000 or $3,000.
But initially, it's programming in the attic in the middle of the night till we started demoing it. Then we show it to people in January for the Pepsi case.
I don't know. It was in January.
January '79.
Was it January?
You didn't demo it. January '79. You use it to do your homework.
Yeah, I used to do my homework. I mean, I talk about that in the TED Talk.
Great while you do this.
The TED Talk, which is an interesting thing that. So the first use for a real business case was on a case for Harvard Business School. The case was about the Pepsi challenge, and the person in it, disguised, was actually John Scully. So it was John Scully who later on ran Apple for a while. And that was the first time. And I talk about that. If you go to TED.com and look at my video, I'll talk about it. I don't have to say it here, give that long story. But we kept testing it, kept bringing people in. I brought in various professors and all who took a look at it and tried it and gave us feedback. Michael Porter gave us advice on how to sell it and stuff like that. Famous professor now. But we got good advice. It was helpful to be at Harvard Business School because you get free consulting from these professors who would charge a fortune otherwise. One of the people who advised us was Jim Cash. Professor Cash is now retired. There's a building named after him called the Cash House at Harvard Business School. He was ended up on the board of Microsoft and on the board of Walmart and among other places. He's a very important professor at Harvard Business School. And he was my professor when I was there. But are there questions? Do people have questions? There are enough people. There are fine. I mean, it looks like there are at least 20 of you watching. So somebody must have a question.
Well, the count right now is 16 people who are joined here. I'm not sure how many are on YouTube at the moment.
There on the YouTube, there's 7, and there are 2 of us, and 2 of them are us. So that's 5 more.
Okay.
So what were you expecting to hear that you haven't heard yet?
I can't really think of anything.
So I guess I'm curious. So before VisiCalc came out, what you hear is like, or at least what I've heard about VisiCalc is like it's the killer app for the Apple II. So like before and after VisiCalc came out, like I'm sure like once the release happens, like your relationship with Apple really changes, and like you now become like a core, like
Kind of, well, they made a competing product eventually with Apple.
Sure. I guess what I'm saying is like, what was the sort of like the rise from being like two people working on a project to like now it's a giant thing and you're like the driving force behind a giant computer company?
Well, they weren't giant at the time. They were tiny. And as Steve Jobs is recorded, I can play you the recording of him saying, if it weren't for VisiCalc, you'd be interviewing somebody else right now. Okay. So they knew how important it was, and they wouldn't ship it seemed like they didn't ship the Apple III until we okayed the release of the Apple III version of VisiCalc. But there wasn't something that you could type in and move over and put in equations, the interactive scroll around and all that. There weren't any you could buy anywhere else. This is new. My original design was using a mouse and not columns and rows, as I say in the TED Talk. The columns and rows came in later. The whole idea is that you can put things anywhere you want. There aren't specific columns and rows. In terms of, so that was, we had this idea for this interactive word processing with numbers. And I wrote one of the first interactive word processors, an early one, not the first, but before Wang had their word processor, I had worked on a word processor at Digital Equipment Corporation that we sold lots of copies of for many years. So electronic spreadsheet, VisiCalc was the first of what we now call electronic spreadsheet. There are some people say, oh, we had the first, because we had the thing that had natural order recalc, which is baloney because it wasn't interactive on a computer screen. Natural order recalc was not an important thing because people bought 100,000 copies of it, hundreds of thousands of copies of VisiCalc, not worrying about that, and used it to great benefit. The important thing is that you could do what if, you could interactively do it on a computer that you could buy and put right in front of you and stuff like that. And then you could get much better output when 123 came out and stuff, that sort. So there was nothing else. Now, we expected to put it on all sorts of different computers real quick. It's on the Apple II first because Bob knew how to do it. An Apple II was available.
Well, the Apple II decision was driven by the fact they cornered the market on disk drives.
Oh, yes, right. That they apparently they had made some deal to get all of the disk drives that Sugar Associates made, all the 5 1/4-inch disk drives, over the ones they had already committed to for a certain number of months or whatever. So that you couldn't get you couldn't get many disk drives for the other personal computers. So Personal Software, our publisher, said do the Apple II first.
So it's the interesting
thing. And we expected to put it on all these other machines. We were expected to have it on the Commodore PET, which we did, the Atari 800, and then eventually the TRS-80, which required a recode.
Well, a bit about that. So anybody know who Brad Templeton is? Who was like one of the EFF people. He's very active in the industry now. He's doing a lot of stuff with robocars.
He's been head of EFF at one point.
Yeah, he was the kid who came out to help us figure out the PET. And that's a whole story. Each computer of those computers had a story. We learned a lot about it. And the Commodore is a whole interesting story in its own right, with somebody in charge of this ROM, somebody in charge of this ROM, and the peripheral buses and stuffing. Then we did the Atari, which is also a much more sophisticated machine, but the disk drive was smaller. And then we hired.
Now, the thing is with Apple first, if I remember right, our publisher, who helped make the decision to do it on Apple first, also and knew about this deal for the discs, also had stock pre-IPO, if I'm not mistaken, stock in Apple, and really worshipped Apple.
Mhm.
And so that would be the first place to put it. And then of course Jobs was pushing, why put it on anything else? You should only put things on business.
Yes.
Mine.
Well, yeah, that's a whole.
Yeah, you've done that with Steve many times.
Yeah, one of the things worth noting is how small the industry was in those days. Like at Comdex, which is the industry show, the principals would show up. So that's why Bill would ask questions about VisiCalc, and he was what party did he have during NCC when he was there? So that's how we got to know these people, because again, this was just all
tiny industry. The industry was smaller than the pantyhose business. There's a video you can watch about that from the BCS. It's one of the Computer History Museums.
Yeah, Dan took a lot of the BCS things. So Seth Sternberg, who did a lot of operating system work at what was the Architecture Machine Group, later became the
Media
Lab. And by the way, I learned a little more because I heard about working with Perkin-Elman and stuff. So we hired him. It was amazing. He was so good that he did a port of the Z80 without ego. That the code matched the 6502 code quite closely, so it could maintain the two code bases in sync.
They were synced where the comments were in only one of them, because it had to say it synced up well, and Bob heavily commented the code. Yay, Bob.
Not overly commented, but heavily.
But heavily commented it.
It was December.
Do an almost line by line translation. The bugs in one were in the other.
And to some extent, we could use the macros to help with that too. So that was important in those days for supporting the machine. And so we did the Z80. And when the IBM PC came out, that was fancy Z80. So we had the same code for the Z80. And each port is a story. Like HP wanted us to port it to the machine called the Apogee. And it was interesting because it had a separate display computer. And to get performance, we loaded our own code into the display computer. And we put a lot of effort into it, which you can ask why, because we knew, and we couldn't tell them, that there was another machine going to be announced the same day they wanted to do their announcement. That was the IBM PC.
And the IBM PC version was for an 8088, even though we had a Z80. So we had to write our the assembler had to be able to do a lot of the work to convert from one to the other.
Well, I think we kept the same code base for the Z80 and the 8088.
Right, but it did require some work, and that was done by Jeff Stevenson, who actually did the conversion. He was in a double locked room with the IBM PC prototype, right? It was a breadboard.
It was literally a plywood board, to be exact.
Plywood board.
And unfortunately, if I knew it, I should have said, "Oh, we lost it" when I came to pick it up.
Yeah. Oh, and or else we would have had the original one. Jeff went on to work at Sierra Online, and then at Microsoft. And we told people, said, "Well, IBM said, are you protecting it well?" We said, "Jeff's a black belt Zen swordsman. You come in
the IBM people don't sign with your IBM name. All the people see they were signing as IBM Visiting Software Arts as if." And we visited Boca when he first did it. It was a whole long story about non-disclosure and everything. But I was told later by Craig Newmark that inspired him. Our visit to Boca and visiting.
Inspired him to do what?
To do Craigslist.
No. I mean, how was he inspired?
Well, he started doing this business and everything.
Oh, to leave. He was at IBM.
Yeah.
Oh, to leave IBM and to have a small business. He was impressed.
But I sometimes wind up with a number of people. Yeah, you don't want to tell them we were lucky. You shouldn't have been that foolish to follow us, but
Yes.
So the IBM port. Then later, we get into some questionable ports. Time, effort.
The IBM port is the one behind you that you're seeing.
Yes.
And that's the one that survived because David Reed kept a uncopy protected of it at some point, and I was able to get it from him. David had worked with us. So we actually had an uncopy protected IBM PC version, a preliminary version of it. And then I got permission from IBM through hook or crook to be able to post it on the internet, so you could run it. So you can actually run the real VisiCalc code in IBM PC emulators that run in JavaScript now. Bob and I have done it on all sorts of machines.
I just want to see if I can find a copy. Do you have?
It's out there. Any IBM PC emulator that you can get that runs, in probably written in JavaScript or something, you can. It probably comes with a copy of VisiCalc, among other things. But as I said, the sounds are different because they probably run too fast, and instead of hearing beep or blip, you're going to hear because
I need to bring up a VM. Unfortunately, Microsoft with the 64-bit version dropped the support for running VisiCalc.
Yeah, you can run. And when I demo VisiCalc, I have to find an old 16.
Like I should be able to bring up
32-bit machine. I have old 32-bit machines that I run in the right emulator,
but you should be able to bring up a 32-bit emulator on this. But
yeah,
I haven't really put in the effort. And we did so. We did port to some other machines, and this goes into the fight with VisiCalc we get to if you're interested. But when we were doing the advanced version, we decided we need better tools. So Seth designed a language which was Lisp-like, or unsugared JavaScript-like, if you want to explain to the kids today, which didn't have garbage collection and reference counts because, again, we're trying to stay small. But it turned out, we wrote an interpreter, and that was a bit too slow. So I had the fun of writing a compiler. And it actually performed pretty well, but it needed a big machine, like 256K. Nobody would ever buy a machine that big. Of course, 123 said, screw it, we'll require that. And it turns out that wasn't a barrier. But, one of the things we did is often over-engineer. Like if we knew, maybe it's a fortune, but if we knew people would buy 32K machines, I might not have been as careful of the coding, which would have been less memory for data and might need a 48K machine. So in those days when people didn't know the value, each of these, design decisions were vital.
I mean, it was hundreds of dollars in those days, dollars to buy 16K of memory. K. It was, if you had a 640K computer, boy, oh boy.
Now, there was still some 4K Apple IIs, but at least the 60K had become the norm by then. Meantime, there are various things, but first, any questions so far?
I think there was some in the chat.
Oh, in the chat, I'm looking. How did you know? Okay, okay. Let me start in the middle. Let's go to the top now. Good. I think to the chat. I need to bring the mouse over. Let me go to the top of the chat. Oh, there's all this stuff here. And here's the mountain situation. First machine was 32K, 12-bit words.
By the way, we don't call it a trash 80. We call it the TRS 80. We give it respect.
Yes, but actually, Radio Shack didn't make it. It didn't have a good visual designer, but the machine itself, was a reasonable machine.
And they were a reasonable company.
Okay, in the 99.4, a little backstory there. I first started speaking to Dan Filestra about working with him to do a basic port, and we pitched TI on the 99.4 to do it. And Ed Esbert was in that group at TI, and later joined them and went on in the industry. The Wang Labs history, and we should add a comment that Dan Berkman's word processor predated the Wang word processor. But the people doing the video might not have realized that.
Yeah. I didn't write it alone. There were 3 or 4 of us.
Yes.
It was written in assembly language for the PDP-8.
And it fit inside the VT100?
Oh, now how do we know that there was demand for a PC-based spreadsheet? Because I was an MBA student. I knew it was,
The simple way, there was demand. Dan wanted it.
I wanted it. I needed it. And we found out real quick when we demoed it to people that business people people who were non-computer people said, of course computers can do stuff like that. What's so special? People who had no need for it said, who cares? I can do 2 + 2.
Yes,
But if you showed it to an accountant or a bookkeeper or something, they would start shaking and pushing credit cards in your face. They were so excited by it because it changed their lives. It made, as some people told us, it made accounting fun. Changed the whole accounting world.
Yeah, but part of the issue in those days was the
Made
dealers.
it too fun.
What? The dealers.
Spreadsheets made accounting too fun.
Yes.
Too fun, yeah.
The SEC charged a lot of us financial IT folks to go and take spreadsheets away from the accountants and make them use programs that actually had accountability for the data they put in.
Yeah. Now the thing about the thing, if you think about it, at least with a spreadsheet, you can look under the hood. Of course, the printout you can't be sure because you don't know what it did, but you can always look under the hood to see how it's done.
But nobody did.
Take the out. They do. You know, but take because if you had to, you would, right?
No, I understand, but a lot of people
look under the hood of ChatGPT.
That's live. You can do it, but retrospective forensic accounting is difficult when the data that was computed in the spreadsheet is uploaded, but the
Right, but the underlying, which is why you need the underlying spreadsheet. I have a niece who is a cousin's daughter who she's a forensic accountant, which whatever. Yeah. But the thing is, at least you could do that if you had some program from somebody else. You had a trust that was good enough, and you know that almost all programs have bugs.
Yeah, and a lot of people don't understand the bugs. For example, when you did an insert, where did it go? There are all these edge cases. Again, we didn't have enough memory.
No, but I'm thinking about other programs, Bob, because he's talking about you have to use, a certified program.
Oh, yeah, no, I understand that, but I'm saying there are lots of traps.
Oh, absolutely.
Yeah, let me tell you about a particular certified program. There was a device that came out called the HP35. It was the first scientific calculator, the one, the type you could fit in your pocket. Very important machine. And HP was they wrote about it in their publication, and they were very proud of the algorithm they used for doing logarithms and stuff like that, and boasted about the whole thing. Well, it turned out if you took the log of 2.02, it came out, and then went back, you ended up with 2. It had singularities at 1.01, I think, at 2.02 and 3.03. Exactly those values, not 2.011999999. And it had and then what about the Pentium bug, right?
Yes.
So there are all these things that theoretically are okay, but there are.
But this gets back to the problem thing. We're so careful about making sure the rounding errors matched what people did by calculators in hand, and then discovered later nobody cared.
Yeah, but the thing what they would do with the spreadsheet is they would do the same thing they did with paper. Is they would frequently have, do crosstabs and things like that. So at least there may be some.
They would try, yeah. But the problem is that no matter what base we use, you'd still get some rounding errors and stuff. We just want the errors to seem right to humans. And
but logic. I think Bill's talking about logic errors and stuff like that.
But but one thing it reminds me is one of the features is error bounds. In other words, significance digits. So if you multiply two numbers, significance goes down. And IBM had a feature on the 7030 which had noisy mode where they fill it with ones instead of zeros. If the two are different, you knew you had a significance problem. So I thought about putting this VisiCalc, tracking the significance digit, but rapidly realized that was a bad idea because after a few columns, there's no significance left. And worse, most of the numbers were guesstimates anyway.
Oh, yeah. Also, I remember now the VisiCalc didn't use precedence. If you did
that was a design decision.
Yeah, there were a couple things for it, but one of the things was that we were going after calculators. People were using hand calculators with paper and pencil, right? And there were two fields of thought in there. There was, the infix type, 1 + 3 equals, and then there was the HP version, which I have one up there, which is 1 enter 2 plus, okay, which was the reverse Polish. and people, which was it and whatever. So we just went with the same as a calculator. The type of it's run this type of the cheapy calculator.
1 + 4 × 3, it would do it as you typed it in, not
as you typed it in.
Which screwed people up because we realized one of the things we discovered with PCs and everything is people, in a sense, more computer literate than we expected. They all can type. It turns out typing would be a barrier. It wasn't a barrier.
They learned to type because of it.
For college, yeah.
No.
What?
There's no word processing when we came out. Nobody had a word processor.
But they learned to type with typewriters, I'm saying, beforehand.
How many people had somebody type their thesis for them?
Some did, but more and more college students had typewriters.
Paying somebody who was executive secretary grade to type the final draft is a different thing from typing your own drafts.
No business person in those days typed their own stuff.
Well, but
yeah. Business school. Business people were offended by the idea that they might do manual labor. Yes.
Well, no, but they didn't type. I mean, and remember, if you wanted to fix, you mark it up and you give it back, and they retype the whole thing because you had to type it real fast.
In business, as opposed to technical fields, it was a class thing, and men who wore suits did not touch keyboards until you gave them a reason to.
So we gave them a reason.
And this went back to a discussion I remember having with J.C.R. Lickladder in about 1971. How do you get executives to use computers? And one thing is get rid of the keyboard. Turns out the answer is much simpler. Make it useful to them.
Give them a good reason why. If they don't, they'll be fired.
Whoever
used VisiCalc got promoted, and whoever didn't.
But only middle managers did.
I take exception to Bill. I typed my own papers when I was in graduate school.
Oh, so did I, but I learned to type in 8th grade.
Yes.
I have my grandfather's
I'm sorry, Jerry. Were you a business major or a technical person?
I was a business major. I have an MBA from Emory.
Oh,
good God!
But, I learned to type in elementary school.
You had me fooled, Jerry. You had the business school full too, I guess.
Yes. My mother brought home typewriters, discarded typewriters for the Board of Higher Education in New York. So I learned to type on 1930s Underwood on the typewriters, which is very good practice for the teletype.
Oh yeah! Oh God! Okay. You were so good on the teletype, Bob. Unbelievable.
Yeah, I hear you there because I had my dad's college portable. And yes, the
portables are even much easier than those old Underwood.
This is my grandfather's that I learned to type on.
Right.
I still have the typewriter I used in college.
You see that? See, when I look at those, I still look at those. The ones I use, that's so much fancier. I'm talking about the uprights with the big.
Oh, I got one of those up there.
Yes,
they're too heavy to pick up, but this is
the one. Two-color ribbon, which Multic supported.
Yeah.
But so learn to type was a very useful skill. And it turns out it's more common than I supposed. But it's still trying to tell people in the 60s that everybody would be typing their papers online and email. Nobody believed it. You're not going to use a computer for such a trivial thing like that. But I think part of the thing there, and this goes back, is both Dan and I had unlimited access to computing because we were on the inside.
Right.
So
in high school.
Yeah. So computers are very expensive, but we were used to, especially I was online since '66. So that was I expected interactive computing, and we worked on screens and stuff. So there's multiple worlds. There's a business world of serious computing, and there was we worked with that world, but we were just used to the attitude that we could be creative. It was a creative medium, and I think that's part of what shaped us.
So let's see, Test Suite, making new sport. We had a whole QA department. I don't know what they used.
Well, one thing I got to say, just a Wang thing. Now, as far as I know, Wang did not do a spreadsheet computer. HP, on the other hand, wanted to do their own version for the HP 83, was it 85? And then later,
85, and we gave them source.
Yeah, and they did a decent job.
That was Tycho Howell, was the guy who we interfaced with, a person I went to business school with.
And later they did the worksite, the spreadsheet only machine that nobody wanted. Turns out you want a spreadsheet functionality, you didn't want a spreadsheet machine. But HP tried. So HP had some interesting stuff, and they did their own stuff. They had a touch input, which is HP 150. They kept trying, but it sort of never became mainstream until recently when they, changed the company and redid them. The deck stuff, well, it was we knew it would never sell.
Oh, let's not talk about that.
And the deck people involved in the same machines agreed with us.
Originally, VisiCalc was supposed to be for a deck machine, not for the Apple II.
Oh, well, that was earlier days. Originally, yes, we're going to do a VT100.
That's before, yeah. I was going to, no, not a VT100.
It was a VT. No,
it was a VD. It was a VDT, I think, or something.
A VDT, which is a VT.
It was PDT. A PDT computer, which is an LSI 11 based machine.
Inside,
it was kind of a follow-on to a machine I had worked on, the VT71, which had a incredible display processor and LSI 11 inside of it and all, which was for editing and typesetting from 1975, I think it was. I worked on the hardware.
A friend of mine was a product manager there, but eventually, realized carrying it on our backs to boardrooms one by one is not going to be the business.
Yeah.
Well, we thought of that.
I'm going to have to go in a minute. Any other questions?
Actually, one other thing I should mention is when we talked about heads-up displays, pointing, and everything, all these fancy graphics things. And the amazing thing is how little value it would have added to the basic spreadsheet functionality. I mean,
We'll see.
No, well, we're going to see. No, but remember, the computer now, we have billions and billions of times of computing capacity.
Oh, yeah. Yeah.
So,
and Bob, there's a question. Do we still have interest in computing software code business? I still code for a living. The last time I wrote code was a few seconds before I pushed. Well, actually, I did some stuff while I was.
Oh, yeah. No, of course, I couldn't survive if I'm not. I wouldn't say coding. I've been spending the last few days fighting with ChatGPT to write code.
I had a very successful app on the iPad right after it came out, it was an iOS developer. Still do a little bit of iOS development. Mainly, I do JavaScript. Bob, you do a lot of JavaScript now too.
TypeScript is my preferred language. So yes, I'm very heavily into the tools and stuff. So yeah, it's for me. It's also the way I deal with ADHD. It's a good calming thing.
GW graphics. The G was for graphics, right? GW Basic.
Probably. Is that what it's called on the? Which was GW?
I don't know. GW Basic.
I thought it was GWiz Basic.
GWiz, maybe. Did it do? Oh, whose was it? We can look it up.
What's the other question? Oh, GW, yeah.
The last thing that Bill Gates shipped software for, I think, was a game for the IBM PC.
I thought it was a Radio Shack 100. It might have been.
That was the last real code for OS code with the RS 100. But then later, when the IBM PC came out, I think he had done one of the games.
We'll play part of it. I got it.
Or something. At least I remember him talking about that once.
Yeah, I mean, the whole PC working from the listings, which actual properties, which bugs were they going to fix? One of the things we had to do is there were bugs in the BIOS, and we had to program it in case they fixed the bug.
Yeah, they couldn't change the BIOS. Everybody depended on it.
No, but they did. No, they actually fixed some of the bugs, and that was a problem. But fortunately, I programmed code that would work with the bugs and without the bug.
Yeah, the technical reference manual up there somewhere. Yeah. I think I have a few copies of it out in the garage.
Yeah, Dan since has done a couple of spreadsheets in JavaScript.
Yep. I did one for the one laptop per child.
Mm-hmm. And that evolved in various ways.
It was SocialCalc.
Oh, one is
it's open source. You can read it.
Yeah. one of the foolish things Dan did was
Ooh,
the
so
super
an OLPC. I have an OLPC right there, about 3 feet from my hands.
So one of the competing programs was VisiCalc, and they didn't support the arrow key. And Dan said, "Oh, what about the arrow key?" And before I could slap him, say, "Don't give them any ideas."
Yeah, no, that was. It's really now, Bob. Let you tell your story because it's hard to come up with a name for things. Who is the company that made VisiCalc? It's a company called Sourcem.
Mhm.
And what is Sourcem? Micro spelled backwards.
Yes. By the way, the
So
spreadsheet.
you're going to tell your VisiCalc, but if you want.
So I had Dan Foster and I were having breakfast at 4 a.m. at
He's the publisher.
Eggs on One on Mass Ave. I assume they're not there anymore. Who knows?
No, you're not.
And basically coming up with names. And my father's company was Telematic, and he wrote the logo with a big T, sort of an antenna that went into the M. So it's sort of a stylized capital M. So I had the idea, was familiar with the intracaps. So that's like visible calculator. I figured, okay, it's a good name, but I capitalized the V and the C and put it into one word. So the logo and the name were the same. And that was not very common in those days. And actually, I was trying to remember the timing. But
Mr. Filestra thinks he came up with a name. You think he came up with a name.
No, but I can tell you why.
He made the decision to use the name out of the many that you had.
No, you're right.
And you both agreed where the name came up from.
Yeah.
So, that you were having fixate on one.
The things that puzzled me.
Like VisiCalc.
I thought Pascal had intercaps first, but Wirth said we did had it first. So I don't know. I didn't really research the history.
Wait, Wirth said what?
That VisiCalc had intercaps first, but I thought Pascal already had them. Because before then, you wrote a variable name with an underscore to separate the words.
Mm-hmm.
And then the intercaps meant you could run it as one word with capitals in the middle.
To use camel case.
Well, camel case is where the first one is lowercase. So some languages can't. They're all these terms, but intercaps.
Unless you're using the first letter to uppercase to mean something, but whatever.
Yes. So that's the origin of the name. So
why would OLPC use QWERTY keyboards? Why not? That's what everybody has.
Yes.
I mainly use Excel for work that I do.
Well, a Commodore.
I end up using. Why would they use no? OLPC had to be used by computer people and everybody else. You don't do something.
The answer is what else would you use?
But I'll use Google Docs when others are using it, when I'm sharing and stuff like that. So obviously, whenever somebody has a Google Doc, I use that.
Yeah. Just keyboards. Turns out all the other keyboards, or at least alphabetic keyboards, do worse. The Dvorak keyboard is supposedly better. Turns out it's not better. So, it's pretty arbitrary. And once you learn it, the real problem I have is fools who use letters in a keyboard arrangement where they think there's a map on the keyboard. Well, those of us who touch type don't know where our fingers are. So if you tell me L key is right, J key is left, that's arbitrary. If you tell me F is forward and Control B is backwards, that makes sense to me. So that's part of sort of the keyboard.
I mean, if you edit a lot of video, you're used to some where things are on the keyboard and stuff like that.
Well, eventually, yeah,
everybody's and that's about to change now. Wait till you.
I know you're really into the Apple VR.
The Apple, it's not VR; it's their spatial computing.
Yes.
Hand input. You can write your own gesture recognizers. One of the examples they have is recognized doing this, and if you can make a heart with your hand, that it means something.
What if you have the middle finger up? Does it recognize it?
It sure can.
Yes.
That's really easy for it to figure that out.
Well, that's a discussion of coming up with sort of popular idioms. So everybody has their own gestures as a teacher. That's more complicated than if there's some common ones. So we'll see how that. Again, we're going to discover how all these things work out.
Yeah. I don't know if hand input is overrated. Well, first of all, hand input is used on phones, and that's been extremely successful. But the hand in the air type one, Apple's is not like anybody else's. Okay, it's first of all, you don't have your hand out here because in fact they tell you specifically, don't use much of that because people will get tired. It's all done basically the same way that you would do with your mouse and stuff like that. Let's wait to see. But all the developers that I've listened to that have tried the new Apple stuff were really impressed with how good the hand and eye input is. It's pretty cool.
Well, okay, getting back to the spreadsheet stuff, Microsoft, of course, did multiplan, and they didn't get the joke in the sense that they thought it was a table that rows and columns with coordinates.
Yeah. Oh, but Kurt, Quest 2 is not the Apple device. Listen to what everybody who's tried it has said, who owns Quest 2s and have tried all those things or whatever, have tried everybody else.
No, I mean, I tried Oculus. It was not.
Well, people who have used the $15,000 headsets, right?
Yeah.
Very well. And when the real expensive ones are somewhat better, this is even better than that.
Look, I appreciate how much time I put in, but it also reminds me. The other thing is, if you look at like Excel.
Oh, and by the way, blind people can use the new the new Apple thing. They have a whole set about how you can use it when you're blind. So it's that's where the touch input is used and stuff like that. Just like if you've ever seen a blind person use an iPhone, they're incredible how fast they can use it and stuff like that. The same thing applies to Vision OS, and they're very concerned about making sure that it will work for people who can't. They really work for the disabled. Yeah, I mean, for example, if they'll do things where I think you can't even use your hands. If you look at something and then continue to look at it the right amount of time or something, they'll then open up a voice input. And I mean, they have all sorts of options. Take a look at the videos that Apple has for the developers conference about input, about the support for disabled and stuff like that.
So let's see. The one other thing I was comment is one of the things we didn't appreciate the value of spreadsheets for presentation, and that's where Quattro excelled, to use a term. And that's sort of a big use case as sort of not to do the calculations, but to present them. And
well,
even
123 had better looking output than we did.
Yes,
and then Excel had better looking output than 123.
So, but Quattro sort of set a standard for how many graphs and stuff it had and things like that.
Yeah, but Excel,
No, Excel now. No, I'm saying this.
But 123 did because 123 had different width columns and it had commas and numbers and it had real graphs.
Did I leave out commas and numbers?
Sure did. That was the big thing. Mitch said apparently that's the first question people asked. Not Mitch. This was Vern. People said, "Does that have commas and numbers and a variable column width?" It does. I want 123.
Yeah,
that was it.
And one of the things is VisiCalc basically decided, we won't go into all the things with VCs, that they wanted to keep us busy on side projects that were going nowhere, like porting to the DEC machines. So we didn't get a chance to do this kind of development that we would have had if we worked together as a single company. Yeah. Unfortunately, they were basically succumbed to the VC madness and wanted to get rid of us where they just saw the cost, not appreciating the engineering. So they even came out with a point to showing why they couldn't afford to pay us anything. And it really soured the relationship when we found it was a fake spreadsheet with mathematical errors.
This is the business relationship between the author and the publisher, and people don't do that anymore because we were the the poster child for not doing that.
Right. Well, the thing is, if they saw us as our engineering department that we worked with, it would work better. But we needed direct contact with the customers to learn and to get features. We need to focus on what they wanted, not going to do useless ports on unusable machines. And look, 123 also did some clunker ports before the IBM PC became a standard, like with Compaq. The other machines would behave slowly because you couldn't get the same high interactive.
You know, for the other machines, they had to do like ASCII writing, like they were writing to a VT100.
Well, and that was also why,
right, as opposed to the IBM PC that they wrote right to the display buffer.
it's interesting. See, this is why it was a good thing we didn't do concurrent CPM, because it had that interface. And later, sort of one of the presidents of digital research who did the process, we were right. It was a bad design to emulate an old terminal because it really didn't get the new high performance screen interfaces.
So people are starting to drop off, but I got to go. It's 8:30.
Oh, okay, I think this is enough.
But Bob, if you want to keep,
let's see if anybody has any other questions. And then I'll get back to trying to figure out how to use DHCP option 12.
So Bob, good to talk with you.
Okay.
Take care.
I'll see you.
Bye, everybody. Thank you very much. I hope you found interesting, and ask Bob for more stuff. He knows so much about a lot of the stuff. So take care.
Thank you very much, Dan.
Thanks.
And
Bye.
Bob.
Thank you.
Oh.
I'm going to switch the background off because the background doesn't go off. Oh, I clicked the wrong thing. Reason is, okay. But as you can tell, you're asking me still programming hacking. You can see the screen behind there is showing my MQTT stream, for example, for the house. But that's a whole separate conversation. So are there other questions? Something making noise. Some helicopter landing? Okay, well, if there are no questions.
I saw Jerry look up at the sound of a helicopter.
Yeah, I heard that I was actually typing some mail to Ron telling him that he missed a meeting.
Oh, well, it's still recorded.
Yeah.
Yeah, do send me the URL when this is done.
Yeah, that's on. Yeah. It's going to be on our website.
Yeah, I can even provide pictures like, working in the attic. Luckily, the apartment I had in Arlington, along Paul Revere's route, we had an attic room, which turns to be the whole another floor. So it gave me enough space to work. So that was very useful.
There's a question in the chat about whether you've ever tried porting VisiCalc to iOS.
iOS, why? I mean, iOS came. The real question is why didn't we port it to the Mac? Okay, and a couple of reasons. When Jaws first showed me the Mac, I was used to graphic screens. A lot of people realize, we knew about this technology. Media Lab had done all this heads-up displays, all this stuff. The challenge was to make it work. And turns out we didn't have the resource at that point to do much for the Mac. And the Mac in those days had less memory than the Apple II, which was up, they'd added more memory to it. So we couldn't be distracted. It didn't have things like a file system. So it's fairly primitive. 123, which basically happened because I told you a story about, VisiCalc, which was originally personal software, basically not behaving well, and not having enough enlightened self-interest to want to basically merge with us, so we have a common thing. So they pissed off their VisiCalc product manager, Mitch Kapoor, who then went on to do 123. So that's some of the backstory there. So you can imagine how differently things could have gone. I mean, it's not a regret. I think done well since then. But just to give you some idea of how the history worked out. So it was. I mean, one of the interesting things is how few spreadsheets were in those days. I mean, The fact that it took so long for people to clone us, and the clones before 123 were actually not very good by comparison, and the first good clone was done by the VisiCalc product manager. So it's a reminder that history is not convergent, that these ideas, as obvious they are now, weren't obvious in those days.
Oh, Bob, it looks like I misunderstood the question from the chat. He was actually asking about whether you'd done anything with like simple apps on iOS or Android to access Chat GPT.
No, I've been playing with mostly TypeScript on the PC. I do. My Dan's done a lot of iOS work, and you got to realize he's working with the Vision stuff. I've been mainly using web apps because I'm interested more in issues of really rethinking computing connectivity. So the stuff in the background, how do you, and this is, I gave the talk on some of my home control stuff and realizing it's not really about home control as much as why would you run a wire to do control when you can have messaging independent of the power? Just like we have the internet is network independent, relationship independent of the path. So that's the stuff I've been working on, and I'm trying to make it public policy for what I'm calling ambient connectivity. So that's been more my focus. But and it was actually Dan who got me to understand that JavaScript is high performance, and it's only gotten better since then. So it turns out, it's a very powerful programming language. So I do use ChatGPT to generate TypeScript code, which is a whole interesting experience because picture my son does like intermediate savant, but it's like a junior programmer who can do some stuff brilliantly, but it's thick as a brick, which is a term, by the way, ChatGPT does not like, and told me we should respect my elders or something. So it'll do great things and then do stupid things, and with the same degree of ease. But no, the programming tools are becoming more fun these days, and we're going to see the future because I wrote an article in the history of programming, and said in the future we're just going to throw the code against the wall and see what happens, and that's sort of what we're doing with ChatGPT now. It'll generate code, but you've got to take responsibility for looking at it to see what it's doing that's brilliant you can learn from, and what it's doing that's dumb you got to fix. But again, that's a whole discussion in its own right. And I think it's a lot of the spreadsheet works are going to go in that direction, that rather than going for precise calculations, you're going to have these AI engines do the analysis. And that's a discussion in its own right, going back to the von Neumann machine, separating bits from the meaning and stuff. But again, a whole topic in its own right. So I keep looking at your cat down there. So see if there's any other question. Yeah. I mean, the thing about simple apps for the Android and things, the short thing is, it's not, if it's interesting, I do it. But at the moment, there's so many people doing apps and stuff. What I really want to do is get rid of apps for Android and iOS and just have basically take the web approach of web apps, and should be able to run it anywhere without installing it. Because I've got like 500 things installed on my Android, and that's just absurd.
Yeah, but if it's a web app, it can't steal the user information and sell it.
Wait. I wouldn't put it past people to figure out how to do that.
Oh, yeah, Google and Facebook sure know how to do it from a web browser.
Yes.
But
The problem with web apps is you can't access them when you're not connected to the internet.
No, you can. That's the whole point of PWAs. They can work. You're running a lot of web apps now. You might not realize it. Like the Washington Post app, I think, is a web app. No, that's the way to write it. So web apps are first-class programming environment that allow you to run standalone programs. That's the value. So if you're into the geek thing, that's service workers will say, oh, the stuff's not there. I'll just bring a cached version in. So that's why I haven't spent time on iOS or Android specific. So anything else, or? Well, if
So
that's
when,
what?
sorry, when people started cloning and making their own spreadsheet programs, did you guys think about having like a legal response to that, or was it?
Well, it's interesting. By the time it became a serious legal thing, we don't, thanks to VisiCalc's bad behavior, we basically got bought out by 123. But Mitch was our deadly competitor. He was also a nice guy, so he sort of bought out our assets, and then they wound up suing Quattro for cloning and some of those efforts. But I was no longer really involved in spreadsheet. I was more into email, and then later on trying to do home networking, things like that. I mean, for me, for Dan, VisiCalc was a direct useful thing to him because he was in business school. For me, it was an exceptional program I didn't use much myself, but it was still useful. I basically like to build tools and share them. So before that, like when I was in interactive data, I wrote a debugger for myself. It became the corporate standard debugger, things like that. I wrote an email program because I needed it, and then other people can use it. But so nobody else has questions? Jerry, it's your meeting. You decide.
Yeah, I guess we're pretty much done now.
Bob, I
Yeah.
have a question in the chat. Where do you see the PC world headed?
What?
Where do you see the PC world headed now?
It's hard to say. I mean, I like the idea of these open platforms, and I think Microsoft is basically try to cater developers a lot, building tools and everything. So I don't like it that they're building as much smarts in. So I'm more looking at a platform. I right now one of the byproducts of writing for in TypeScript is I'm more platform agnostic. There's still the vast bulk of the tools are Windows only, so stay there. But even Windows, it runs Unix very well. WSL, I can run Unix apps. Beyond that, the worry I have, well, it's always been a case. People call digital literacy the ability to type. I guess if you view things as digits, it makes sense. Or, if you use Facebook. But the real thing is, I want to transcend the computers for the basic concepts. So it's hard to say. I mean, again, you saw Dan's excitement about the Apple visual interface. I think it's going to be interesting. I don't think it's going to replace this. But the real question is where can we build a tool? So it's hard to say. Right now, I want to focus on basically more about devices. In other words, there's programming the PCs, the web, but I'm looking more what you can do with physical devices. So all the Shelly devices I have, well, you saw the last meeting. I was playing with those. So that's really what interests me. How do we basically merge computing into the physical world and move the distinction? But I mean, large language models work by that. Everything is squished into bits. So we're going to see what happens when we transcend the physical.
Will our desktop machines be museum curiosities?
What is a desktop machine? Because I think the problem with these silly things is they're a pinhole. There's only so much I want to do through this little pinhole. So I want various form factors. And this is where the term progressive web apps comes in. That it's not mobile first, portable Windows. It's sort of large area, small area. And how do you use each one and the richness? So I think that's more the issue of, whether it's on a desktop or laptop. I mean, I find I don't get as much done on the road because I'm used to, let me see if I can get this up. Oh, yeah. Having a couple of screens. Okay. So that I can put things where I want to, can use, all of the capabilities. So it's not the desktop machine per se. I think we need to remove the distinction between like television, viewing surfaces, various purposes. So we're still in the early stage. The question is, why do we still have a thing called a television? That's a strange concept. So And as computer becomes cheaper, hopefully all these little boxes like Roku's and stuff will become first-class computing engines, and we'll be able to, just use web apps for all purposes. And I really think, we're going to, for a while, the browser engine is going to be a nice computing platform because it is very portable.
The thing that worries me is like having all these little boxes everywhere, and then having to implement like the complicated web standards for all of them. Like there's just so much room for error in doing that. So my worry is like someone's gonna, like I buy a new smart plug from TP-Link and they only update it for 2 years, and then I'm like,
no, okay, so the whole smart plug stuff is really dumb. Okay, because this is why I want to use generic web interfaces, HTTP things on the devices. So with my Tasmota bulb, I just go to the web interface. I don't need any other tools. And then, where most of the smart plugs are into silos and separate apps, I'm more interested in sort of open interfaces so I can maintain control, even if it's not updated.
But I'm really like, so the example I gave of TP-Link, they make smart plugs that use like open standards for
what open standard?
Matter is the new one.
Oh, the Matter, that piece of crap.
So yeah, I agree with you. I guess what I'm trying to get at is like, I'm not so much concerned about not being able to interact with the devices in the future. More that like, I'm just concerned that the manufacturers will not be able to keep them secure in the future, especially if they have to implement a web stack as like, and try to keep that future proof. Like that's just really hard to do.
Okay. The device themselves do not need to implement the web stack. They don't have browsers. Remember, your server is orders and orders of magnitude simpler than the thing. So those devices really should just have HTML, HTTP servers, which are much simpler.
So like my job is exploiting HTTP servers, and there's a lot of error in HTTP servers.
Like what?
Like just parsing HTTP is often done incorrectly. Just like determining where the headers end.
No, this is why I use Express now. For example, on Android, on Node. If you know bugs in Express, it's a package which takes care of the HTTP part. And HTTP itself, I mean, I've written raw to sockets, is not that complicated enough to get into quick and trying to be fancy. But for the most part, an HTTP1 is sufficient. And I wrote my own package for handling SQL, so I'm safe from injection and things like that.
I guess like, you can
Matter. I don't trust for that reason.
All I'm saying is like HTTP1 is a simple standard, and you can read it and believe that you understand it, and then like there's just a lot of room for error in implementation. So for example, there was one server we are now able to talk about it. We found a denial of service where you say that the content length is the negative length of the message, and it wasn't checking the sign of the content length. So it'd skip backward and reread the same message again, and it would infinite loop doing that. And there's like all sorts of weird room for problems you would never expect.
Yes. No, I'm very interested. I'd be very interested in continuing. Send me a note, because I maybe can write a column for the IEEE Consumer Electronics Magazine, we won't talk about IEEE not understanding any of this stuff. But I'm very interested in connecting devices, the vulnerabilities, because part of my ambient connectivity is firewalls basically give the illusion of security. Okay. But a lot of our devices don't have that. So I wrote things like, how do you manage virtual communities of devices? How do you handle, like one of the things I wrote, I'll put it in here. Is what we need to get rid of the idea of putting semantics in the DNS. That's one of these terrible, terrible ideas, because it doesn't guarantee security. Matter of fact, it creates vulnerability by simply, the name match doesn't mean anything. So we need to basically teach people about GUIDs, binding identifiers, and things, so we can start to maintain. Don't try to fold all things into one mechanism. So that's a start of it. We need to get rid of, so now you depend upon topological security. We need, there are many ways. We need multiple levels. Like it's not secure, insecure, it's trust relationships. So I should be able to work with the site before I log in until I need to establish credentials. And then there might be multiple levels. And Jared Spruill has spoken about some of that also. So yeah, there's a lot we're learning. And I wanted to, at the same time, open everything up, make them all available. At the same time, realize it's going to take us a while to learn how to operate in this new environment. Yeah, our instincts betray us, but then they always have. I mean, the reason why the term con in conning somebody comes from confidence. You basically learn how to hijack the mechanism of trust. So no matter how much security you're doing, you've got one real vector that can get through any of security barriers. It's a very squishy vector. Humans. You can do whatever you want, but if you do you know about the teddy bear attack? Okay, people were warned there's a virus going around your computer, and if you look at in the Windows directory someplace, there's a teddy bear icon. Delete that file. That was a Java engine. So people can easily be conned into doing arbitrary harm. So no matter how much you put up security barrier, and Multics, they put up a very big security barrier, and in order to get work done, you had to get around it. So what makes it most difficult is that the people you properly trust might be wrong, or what you did in the past might now be sabotaged. So it's a messy thing, and the real question is, how do we survive all these attacks? We're not going to prevent them. How do we survive them? And how much time should we waste on on the trivial or unlikely attacks? Like, do you lock your doors, but you still have windows which are easily broken? So we have to get the right balance. But I think there is a new thing that you're getting to, is the fact that we can have remote attacks at scale. And I really worry that the primary use of ChatGPT is going to be find these things and exploit them. So don't worry, the next species will appreciate the planet we left them, especially the Venusians. Is that too dark? So, any other questions?
Sounds like we're done.
Okay, hopefully.
Okay, thank you very much, Bob.
Thank you, Bob. Great show.
Okay, so send me the link when the video's there.
I did.
Okay.
Thank you.
Okay, look. Okay, look. How do I undo this? There's got to be get out of here. Oh, here, the hang up button.
Really important questions. There might be some, visionary on the line, you ask them.